Today we're going to talk about solving right triangles with trigonometry. San Francisco, California is famous for its steep streets. The steepness of a road is often expressed as a percent grade. Filbert Street is the steepest street in San Francisco. It has a 31.5% grade. This means that the road rises 31.5 feet over a horizontal distance of 100 feet, which is equivalent to a 17.5 degree angle. You can use trigonometric ratios to change a percent grade to an angle measure. Let's use a triangle and trigonometric ratios to determine which angle of the triangle is angle A. So cosine of A is equal to 24 over 25. Cosine is the ratio of the adjacent to the hypotenuse. So cosine is equal to the adjacent over hypotenuse. We can write that out and substitute in 1.4 over 5 and 7 over 25. The leg adjacent to angle 2 is 4.8, so the hypotenuse is 5. So we can put in angle 2 as 4.8 over 5 equal to 24 over 25. Since cosine A is equal to cosine of angle 2 is angle A. So we're just finding the cosines of both of these by plugging in the numbers and seeing which one matches the one that was given to us. We're going to use the given trigonometric ratio to determine which angle of the triangle is angle A. Here we have tangent this time, so we're going to say tangent A equals 1.875. Tangent is opposite over adjacent. The leg opposite angle 1 is 27, and the leg adjacent to 1 is 14.4. So angle 1 is 27 over 14.4, which is 1.875. The leg opposite of 2 is 14.4, and adjacent is 27, which is equal to 0.53. Since tangent of angle A is equal to angle 1 is angle A. In lesson 8.2, you learned that sine of 30 is 0.5. Also, you know that the sine of an acute angle is 0.5. You conclude that the angle measures 30. This is written as inverse sine of 0.5 equals 30. If you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric function to find the measure of the angle. The inverse trigonometric functions are as follows. If sine of the angle A equals x, then the inverse sine of x equals the measure of the angle. And the same is true for all of the functions. We can use our calculators to find the angle measures to the nearest degree, because oftentimes we won't be able to calculate them in our heads. So we use second cosine, and that'll give us that inverse cosine, second cosine 0.87, and press enter, and you should get approximately 30 degrees. Make sure again that your calculator is in degree mode. If you aren't getting these answers, double check it and make sure that it says degree, not radian. Letter B, we're finding the inverse sine of 0.85, and you should get approximately 58 degrees. Inverse tangent of 0.71 should be approximately 35 degrees. Using given measures to find the unknown angle, measures, or side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know two side lengths or one side length and an angle. To find the unknown measure, we want to round lengths to the nearest hundredth and angle measures to the nearest degree. If we want to use the Pythagorean theorem, we could say RT squared equals RS squared plus ST squared, which is C squared equals A squared plus B squared. We know 5.7 and 5, so we can plug those in, and we find that ST is equal to the square root of 7.49, which is approximately 2.74. Then we can plug in measure of angle R equals the inverse cosine of 5 over 5.7, which is approximately 29 degrees. Since the acute angle of a right triangle are complementary, measure of angle T equals 90 minus 29, which is 61 degrees. So we know that the missing side was 2.74, angle R was 29, and angle T is 61. We can start by using the cosine function, the inverse cosine, where we have inverse cosine equals measure of angle R, and we get 29 degrees first. Then use the acute angles of a right triangle are complementary to find angle T of 61. Then use sine of R equals ST over 5.7. So ST is 5.7 times sine R. and then plug in ST approximately equal to 5.7 sine of that large expression, which is equal to 29 degrees, which we found up above. So 5.7 sine 29, which is approximately 2.74. Solving a right triangle on the coordinate plane can be done as well. If we're given the 3 points of a triangle PQR, we can find the lengths to the nearest hundredth and angle measures degree. To find the side lengths, we have to plot the points. Next thing we do is count the number of squares on the right angle sides, so the two legs. So PR, if we count, is 7 units, and PQ is 5 units. Using the distance formula, or a Pythagorean theorem, we find that QR is equal to approximately 8.60. Now we need to find the angle measures. PQ and PR are perpendicular, so their equal measure of angle P is 90 degrees. PR is opposite angle Q, and PQ is adjacent to angle Q, so we can say the inverse tangent of 7 over 5, opposite over adjacent, is approximately 54 degrees. The acute angles of a right triangle are complementary, so measure of angle R is approximately 90 minus 54 degrees, which is approximately 36 degrees. Here's your lesson quiz. Take some time to practice these. See if make sure your calculators and degrees are working fine. And then go to the next slide and try to figure out some of the triangle solving.